Hello everyone, you are welcome to GMAT 41's channel. In our physics class today, we are going to continue from where we stopped in dynamic motion. We shall be giving attention to Newton's third law of motion. You would recall previously, that was in the GMAT 41's live stream physics section when I taught you dynamic motion. We looked at Newton's first and second law of motion, where we explained that in first law of motion we gave attention to the concept of inertia, a body maintaining its state except somehow an external force acts on it. I went ahead to explain the concept of the second law of motion by Newton, where we established that wonderful equation that the net force F is equal to mass times acceleration. And so we will be looking at the third law of motion, where we would see what happens to action and reaction. So once again, you're welcome to our class today. All right, let's move on straight to deal with this Newton's third law of motion. It's going to be a wonderful class, Can always count on GMAT 41. So I've got a special package to deal with this aspect of dynamics. So to start, we are going to look at what the law states, okay? And then we would consider wonderful examples to explain this Newton's third law of motion. So, what does Newton's third law of motion state? Newton's third law of motion states that every action produces equal but opposite reaction, which means if you carry out an action, you want to expect a result. You want to expect a result. Now the result is going to be opposite to the action that you took. That result is a reaction. And you see, this is a very wonderful aspect of life in anything we do. The truth of the matter is, whatever we do in this life, we expect a result. Even when it comes to our studies, as you study in school, preparing for your examinations, it is important for you to know that this law is also applicable to that. If you study well, you expect that there is going to be a result to that. Now let me tell you something, when you are studying, sometimes it's not going to be quite easy. For example, following up with the GMAT 41's classes, whether it is online or our physical tutorial in Unize campus, either ways, the truth is, our body would always want to tell us, you just got to rest. You have to sleep. Even when you sleep for let's say 8-10 hours. You get your book, you want to study, and then the body system is telling you just have to go rest. But now let me tell you, you have to pummel your body, right? You want to discipline your body so that you tell that thing that is trying to push you to go rest the time you are supposed to study. You tell that thing, please, let me be, So you try to insist. It's a kind of mounting pressure on yourself to study. So that process, that action might not be easy. But let me tell you the reaction afterward. Some persons might consider that, they're undergoing stress to study. Don't worry. That stress, if handled well, and if you do the needful, is going to lead to an equal but opposite reaction, which will show very well in your result with fundamental A splashes. And you know what? With first class in view as the only language that GMAT 41 understands. So what are we saying in essence? I'm trying to let you know that any action taken will produce equal and opposite reaction. Now think of a situation where you give in to that thing trying to discourage you. You don't just want to study, feel like it's stress. You don't follow up with the GMAT 41's classes. You don't follow up with your lectures. Or maybe if you go to lecture, you pile up everything you dump. No time to study. You are flexing. Okay, you have finished that. Do you know what's going to happen? The equal and opposite reaction is waiting. Although that would not be good. Because eventually it will tell in your results. Maybe when results comes, you'll be seeing, there's something they used to tell us those days when we were in school, the deaf students, DEF. But please, of course, operating with GMAT 41, this is something none of you should aspire for. You are a student. Yes, you are what? A student. from this platform, whether through our online classes or the GMAT 41's physical class, the truth is you are going to be coached, mentored, so that when you sit in for exam, your examiner cannot dribble you. You will hold them to a standstill. All right, I try to quickly apply these, Newton's third law of motion to your studies so that you have that in mind, and then please be serious, work hard, okay? And then, although stress will be there, but there are every way for you to control that stress. And one of the way is identifying with GMAT 41 in your studies to reduce your stress, yet getting excellent grades. Now let us come to physics now and see how we can apply this Newton's third law of motion. Remember, it tells us that every action will produce equal, but what? Opposite reaction. So let me assume that I have force 1 acting on 2. Okay? You have maybe an object, the object is coming with its own force, let's say force 1. Then it's coming against this object, and this object has its own force. We are calling this object object 2, so it has force 2. So if you have this 1 coming with its force, now the force that this object, this black marker for example, exerted on this blue marker, which I'm going to use, let's say F12, that is force 1 on object 2, will be equal but opposite. I'm going to use negative to show that it is opposite. Will be equal but opposite to the force that object 2 will exert on object 1. That is the whole concept of Newton's third law of motion when we express it mathematically using this concept of force. Is that okay? And I want to quickly tell you something, that this knowledge of Newton's third law of motion is very well applied to the study of momentum and the law of conservation of momentum. Yeah, we are going to treat that as we move on in this course. And in fact, under statics, where you deal with the concept of equilibrium, you could hear something like clockwise moment equal to anti-clockwise moment, right? That's also a technical application of Newton's third law of motion. We are saying that the guys will be equal but opposite. Imagine that maybe you hang a force here and a weight, and it's pulling this marker that you say to be rotating this way. Are you following, right? In the same way, you notice that as this part is coming down, it's pulling this part what? Up. Equal but opposite. Alright guys, we don't have much to deal with in terms of the equation for now in application of Newton's third law of motion. However, it's important as a student to know some classical examples, of the application of Newton's third law of motion. And for that reason, to make this class, as always, an interesting one, I've decided to arrange so that we would make a trip. Is that okay? We want to see some live application of Newton's third law of motion. I'm going to take you to Beijing. Is that okay? I'm taking you to Beijing. So we are going backward to 2015 to watch what happened in the Olympic. We are going to meet with Usain Bolt and his crew in a 100-meter race as a classical application of Newton's third law of motion. Please watch as we move on to Beijing. Now you observe that in the Olympic, these guys, they are set to take on a race. Please watch. You'll observe that their legs is pressing backward on a leg support. Are you seeing that? Yeah, on a leg support. If you watch race regularly, you will observe that there is this back support always provided for these athletes. So that before they take off, that their back leg, the foot, will press backward on that support. There is a reason for that. Now that leg back support helped to propel them, to push them forward. So what is the idea here? There is an action which is as a result of their leg pressing back on that leg support, that foot support. So that backward push by their foot made the foot support to push them forward, and hence they took off. Action and reaction are equal but what? Opposite. Backward push, forward propulsion. Alright, watch on. And as they move, you will still observe something. Watch the foot of each of these athletes. You notice that rather than stamp on the floor, that is on the ground, fully with their foot like this, you notice a kind of inclination, and there is a reason for that. Watch their foot, you'll see. It lands this way often. The reason is to help this ridge part of their foot to press back on the ground, and then the ground helps to do what? To push them forward. So this is a life application of Newton's third law of motion, that every action will produce equal but opposite reaction. And of course, you watch the race, we are enjoying this in Beijing. Alright? Finally, that guy did it as usual, Usain Bolt. When I finish growing, I would compete with him. I would defeat him. Don't go there. That guy is great when it comes to race. So we've seen that, and that was quite interesting. It's an application of Newton's third law of motion. As you've seen the race, I like to say clear that even when it comes to our walking movement, are you following right? We also apply Newton's third law of motion. Because what usually happens, we place our foot on the ground, while trying to move, it goes up this way. The edge of our foot, right, will press down on the ground, then the ground helps us by friction to push us forward. Alright guys, we are going to see another life application of Newton's third law of motion, this time around to driving. Make sure you stick around, because I'm going to take you to another high technological application of this law that we are treating now. But next, we are going to see its application to driving. Please watch the screen as we see what these friends do. Now you can see two of them inside this car, and let's watch the car move.
Stop.
That's good. Now, watch as they stop. Good. Did you observe something?
Okay.
Once the lady, perhaps teaching the other one how to drive, it's likely a driving test, said stop, you noticed a forward movement. Now when you hold or press down as a driver, you press down on the brake of a car, it is as if that stopping process is as if you are trying to make the car to go backward. Is that okay? Instead of forward. Now the passengers, the drivers seated inside the car will usually move forward as a reaction to that action of trying to stop the car. You press on the brake, the car stops, and then people sitting in it will do what? Move forward. So there is a backward and forward reaction. Backward stopping of the car, which is the action, and then forward movement, which is the reaction. If the car is to be moved suddenly again, you will notice that the car moves, the driver and a person seated inside the car will go backward. Again, another application. Forward movement of the car, backward reaction by the passengers because they'll go backward. Because that's why it's always advisable to, put on the seat belt while driving so as to avoid much of this force, opposing forces. Alright guys, I hope you're learning right and seeing practical life application of Newton's third law of motion. Finally, I would like us to take a trip to visit SpaceX as they launch their Starship. Please come along with me. Let's make this trip to visit them. Watch. Now you see the Starship is about being launched. Watch what is going to happen now. Wow, this is incredible. You can see this gas being ejected, alright? And then let's watch what is going to happen. This is interesting. You can see the takeoff of the Starship, right? That's good. The question would be, what propelled this thing upward into the sky? And you notice that it's as a result of the ejection, the removal of the gas, alright? The gas that is being ejected from perhaps, let's say, the exhausts, as you might just likely understand it to be. You notice that there was this load of gas being ejected Now, it was being pushed downward, the gas, and that led to the propulsion of the starship to space. Action, reaction. They are equal but opposite. And so, friends, you are welcome from our trips to seeing these live applications of Newton's third law of motion. I hope you enjoyed this class. Please subscribe to this channel, like this video, and share to all the friends, okay? You can become our channel member, like I said. Click on the Join tab and then select the Platinum package. Become our channel member where you learn more the concept of physics, chemistry, mathematics. And if you are a student of UNIZIC, especially say in 100 level, and you are interested in joining a physical tutorial class, the GMATS 41 is right there with you. You can contact me on the number showing on the screen in order to get to know our venue. Join us so that the GMATS 41 will coach and mentor you, prepare you towards your first class in your 100 level. Don't waste time. Feel free to entrust your 100 level academic journey to GMATS 41 and you can just be assured of the best with first class in view. Alright guys, in our next class we are going to go back to Newton's second law of motion. Are you there, right? We're going to see how we apply that Newton's second law of motion to solve several problems in terms of forces. We are going to give attention to the catalog of forces, the 4 common forces, where we are going to apply Newton's second law of motion, F equal to ma, to do our analysis and solve good questions. We are going to deal with the normal force, we are going to deal with the tension force, we are going to deal with the frictional force, we are going to deal with the spring force. By the way, frictional force already is available in GMATS 41's YouTube channel. You can click on this info link and it will take you to the lesson on frictional force. So we'll give attention more to tension force in our next class. I hope to see you in that next class. Until then, remember to take your studies seriously. And don't forget how we also applied Newton's third law of motion. Action will produce a reaction which is equal. Don't forget its application to your personal studies also.